Something interesting I would like to mention here, that when we construct this string memory, a memory buffer object that will contain all of the text that we can just read using standard stream operations. When we constructed, we populated initially with all of this. And notice that individual literal strings enclosed inside double quotes are placed one after another without semicolons or commas or anything. It's just basically one string that follows another string. C and C++ preprocessor works the following way. When it finds a string, okay, and it finds that it is followed by another string, it automatically concatenates them together. And so therefore, it's just a convenience that we can, instead of writing something like this on a very, very long line that would just run away from the width permission of my screen, right? Instead, we can break down string literals into manageable chunks or fragments that just follow one another. So this is what is being done over here. So this is convenient and quite reliable feature. So this is done because preprocessor will recognize it and make no mistake, everything that's in here will be concatenated into one long string, and this one long string is going to be placed inside the string object which we construct over here. Okay, so this is just an observation. So let's proceed with the next step. And of course, the next steps are going to be, I suspect, is to take care of the creation of the actual game class, and it will have its own header file and its own implementation, I suspect. So let's see what we do here. So this is the discussion of the logic of this program as we just mentioned. So I'm not going to read all of this to you. This is for your information now. Also just something to indicate before we proceed to the actual implementation. Also something to mention is that the game, the int of the game is constructed as a new object each time we continue iterating through this loop. So every time we begin another iteration of the loop, which is an endless loop, we construct the instance of the game class, right? So for each sentence, so basically, the game works with a single sentence. And here, so this game object is constructed as many times as there are sentences inside this text buffer right here. Okay, so we just keep reconstructing and reconstructing it with every sentence, which I suspect when we destroy this object and it goes out of scope and is deleted from memory, in its destructor, it needs to deallocate or detach the existing text rectangles from the window, because we would like to prepare for the next blank screen. Just my observation that this object is constructed multiple times as we proceed through individual sentences that we will be displaying on the screen. Okay, so back to the discussion about the games. So we say add game.h header to our project. The same routine. We go to the project directory. We go under source, and under source we just oh sorry, I'm looking at the wrong project. Yeah, so this is lab 3. This is our source right here, and no, sorry, this is my project right here. Okay, yes, for window, no, labs, final project. I found it. Source. Okay, so here we go. So we have our text rectangle, and so the next new header file that we'd like to add is named, again, just select file name and file extension, replace it with game H and say yes. And so this is what we're going to create. And I suspect that we also need to create a new implementation file for it as well, which will be called game.cpp. Change that. So two new files, obviously, two new files which are blank, but now we have files that we can use to continue our laboratory here. And we can naturally just drag and drop both of these files over here. Both of them are empty files, but at the same time, of course, the implementation file has to be added to the list of the source files for our project. So more about this later. So right now, let's just make everything visible side by side. This is our handout. And this is our actual environment. Okay, so the first order of business is to take the code for the header file and copy it over to the actual header file. And notice again that it contains the header guard, but just to underline this one more time, remember that in C and C++, all header files must have header guards, but they must be unique. So this is why I always take the name of the file and derive my header guard name, which should be unique, from the name of the file. So I'm assuming that the name of the file is sort of like unique enough to make it unique. If it's not, each header file must have a unique header guard, right? So sometimes it's tempting to copy and paste from existing file into the new file, which is okay, but remember to change it. You need to change this to something that would be unique, most likely corresponding to the name of the file. Just this observation before we continue. Okay, so we have the starting point for our header file. Okay, let's proceed. So we're done with this part. And then copy and paste the game class declaration into the header file. Of course, all the content is going to appear right here, directly inside. And this is the declaration of the game. So game is a class which will appear right here, and that's what we do. And so it has a public constructor so that it can be constructed. It has the destructor, which apparently will be taking business of removing old content from the window. It has read sentence, load next sentence from the input stream ISTR, returns true on success, false otherwise, and make all words in the sentence visible. Okay, so we have another function that essentially we read sentences and then we unhide words, we make them visible. But read sentence can return true or false. If it's true, it means everything is okay, the game should continue. If the return from this function is false, it means that we couldn't read sentence anymore, so we have to stop. Now, in my main GUI, I noticed that we're passing win in this handout. It's a typo. We need to be constructing the game with, of course, with the stream class object, because that's what the constructor is expecting. Sorry about this. So this is right here. This is a typo. Instead of win, this should be using ISTR like I did over here, okay? Because that's how constructor is expecting it. Oh, actually, no, I apologize. It's the read sentence. Wait a minute. Read sentence. No, sorry. It's all okay. Yeah, we have the window and we have the ISTR. I apologize for this. I was looking at the header file, and for some reason I was thinking that I'm looking at the constructor over here. So no changes, no, everything's okay. All right, so this is the declaration. Of course, we're expecting this to be all implemented, and there is also an internal function, internal implementation function, which is private, which can be used inside the class game itself, that says add word. So it will basically take the next word and take the indicator whether the word is hidden or not, and add it to a list of words that it will contain. All right, so this is in basic organization of the game class. Very good. All right, so then, okay, so we were looking at this portion here where we moved declaration of the game into the header file, and now we have new class game. And so, of course, it requires implementation, but before we proceed forward, we also add 3 member variables. I copy these 3, and I will also add them to the private portion of our implementation. So internally, we will have a vector of hidden words. Apparently, this is a vector that indicates indices of the words which should be hidden, and it also contains a vector of rectangle instances. Right, so remember we constructed this text rectangle class a while ago, and now we will be having the entire vector of references to these objects. So we have 2 vectors. One is called hidden words, and another one is called T-Rex, and we have a reference to the window. So let's just try to make it all visible here. Basically, a game class has a collection of these objects. Right? So it has a collection of these objects. There are multiple objects of the type text rectangle that the game can keep track of. Apparently, it will also be creating them as well at runtime. And there are a couple of vectors that take care of the hidden words and the collection of these rectangles. We also have a reference to the window here as well. So the game class also has a reference to the window. Okay, so it has access to the window right here. That's what I can see from organization of the game class as we keep learning what it contains. Okay, so this is fine. I'm just trying to keep this picture in view. Now it's time to do implementation of everything, implementation of all of these functions. So what I'll do, I just like copy and paste all of this, right? Game constructor, game destructor, read sentence, unhide words, add word. Press a copy and go to implementation, which is game.cpp, and hit paste and get rid of this private, which I don't need. And then let's align everything. I select the multiple lines by pressing Shift and hitting down arrow key, and then press Shift Tab to remove the indentation. The first step that I will make here is to get rid of these semicolons, which don't belong over here. So just one by one, delete them from implementation. Semicolons are needed only in the declaration of these member functions. And then each name has to be prefixed by the scope of the game class, like this. So again, a funny looking game. This is a constructor of the game class. The destructor is right here. Okay, so the destructor of the object has a tilde symbol in front of the name, and this is how destructor is recognized. And destructor is invoked every time just before the object is going out of scope. Destructor cannot stop object from going out of scope, but it can do some steps that we may consider to be when the object is destroyed and disappears from memory. So continue to add this prefix to every function. Right, so read sentence is the next member function that needs qualification, and then the next one is unhide words, and then the next one is add words. Okay, so we're having this prearranged disposition of everything that needs to be fully implemented. Of course, there is no implementation of these functions anywhere in this file yet, but this is what we have the handout for. So now, how do we handle constructor? Well, apparently what we're going to do is here, we're just going to use the initializer list to populate window reference with window reference, and the rest of the constructor is empty. So I'm just going to copy this and paste it really anywhere like this. I would like to indent the initializer list. So once again, this is our game class, and it has a reference to the window. And so we need to initialize reference as soon as possible in the constructor. So in our constructor, that's what we do. We initialize a reference to the window with the window reference that was provided to the constructor. So now we have a reference inside the game class to the window class. Then there's a proposition to implement read sentence. Okay, so this is our read sentence right here. So its implementation comes here, right? So we just take this implementation and copy and paste. Again, I will indent everything the way I like this. And so what does it do? What does this thing do? It's really read sentence is this attempt to get next sentence from the implementation from the buffer containing the text, And so what we do here is that we proceed and start reading information from this buffer. How do we do this? Well, we say that to be able to complete this work, give us a reference to this buffer. So this read sentence function, its parameter is a reference to this buffer of information in computer memory that contains some text. We declare a variable named word. We assume that this word will not be hidden, and then we proceed to read the standard way. If you recall, we've done this many times. So with any type of input stream like this, it's perfectly fine to say, okay, let's read some information. And we say, okay, we just hit the period. Remember, we agreed that the period should be found at the end of every sentence. That's our input format. And once we have it, we immediately return and say everything is perfectly fine. We found another sentence, so it should be ready to be displayed. So if this is not a period, then the possibility that this is an @ sign. An @ sign indicates the beginning of a hidden word, the word that initially should be hidden. So recall that, let me now resize my window, and again, remember that we organize this vector of hidden words. So what we do is that we look at the size of the current a collection of rectangles, and we say that this next one that we're about to insert into the vector, which will have this index at the tail of the vector, should become a hidden word. So here, as soon as we hit the @ sign, we insert new element into this vector. Then we say that this word that will be processed next should be considered hidden. And we set this temporary Boolean variable hidden to true. Remember that initially we assumed that hidden is false, that the word should not be hidden, but then we decided that it should be hidden if we encountered this symbol. And we say continue to say, okay, now let's read the word, the next word, which will be hidden. So when we read the word, we just skip over these two, and then we call add word function, which will add the word to our structure, and we also already have an indication whether it's hidden or not. And as soon as the word is inserted, we reset hidden to false to assume that the next word will not be hidden. So this is, in this loop, we read input, and we're supposed to be able to distinguish between the ending of sentences, the occurrences of hidden words, and any other words that we will be adding to our collection of words and entire content that we need to be able to manage inside this game class. Okay, so this looks fine. I will save it now, and let's break this recording segment.